This is a work that actually is an extension from two previous pieces of work that we published a few years ago. And in line with what my lab has been working on in terms of identifying novel targets for targeting in cancer cells. And just to give you a little bit of background, mutations of KRAS, which is a gene that drives carcinogenesis, the process of cancer formation, these mutations are very closely associated, particularly with pancreatic cancer, colorectal cancer, and lung cancers. And so the conventional dogma has been to identify small molecule inhibitors of KRAS, so you can block the activity of this protein, which is involved in cell proliferation, cell growth, and cell survival. And so this particular work, as I mentioned before, is an extension from a small molecule that my lab has been working on for a number of years. And we had previously shown that this small molecule seems to target cells that carry the mutant form of KRAS. And so in this particular paper, we think it's important is because we very comprehensively have basically described the mechanism by which it selectively targets, or I would say targets particularly cells that carry the KRAS mutation. So in this particular paper, we took colorectal cancers as a model, but we also show in different other forms of KRAS-driven tumors, particularly pancreatic cancers and others, that the molecule seems to hold its activity. And most importantly, we show that here, instead of inhibiting RAS, we're actually able to show that the molecule works by overactivating or hyperactivating the activity of KRAS. And so you would argue that why would you want to do that for a mutant protein that drives carcinogenesis? So one of the functions of KRAS is also to induce oxidative stress in cells. And so we leveraged on this by showing that if you overactivate KRAS, you induce metabolic stress in the cell to a point that is beyond repair. And the cell then succumb, they undergo mitochondrial damage, and ultimately are executed. And so the novelty of this work would be twofold. One is to show really a proof of concept that here is a model where we can look at it differently by targeting cancer cells that are addicted to KRAS via activating KRAS rather than inhibiting. So in other words, allowing the cells to drown of their own addiction. And second important thing would be giving a novel strategic way of designing new therapeutic strategies where you could now look at drugs that have already gone through FDA approval, and you could repurpose them for selecting molecules that may have similar activity. So we are very excited about this. Yeah, I mean, in terms of looking at areas where we might want to maybe focus a little bit more in terms of investment, so I think there are maybe 3 or 4 areas that I would highlight, and there may be many others, but I think that one area that is particularly in need for more funding and probably more collaborations is an area where technology can actually come abreast with the biology of what we are finding. So if you would recognize or appreciate that over the last maybe couple of decades, technology has really leapfrogged, particularly in the context of informatics and computational biology. So I think areas where we can bring together the biologists, the cancer clinician, the clinician scientists, and people from the computational and bioinformatics area would be an area that we need to maybe expand more. And in that sense, I guess, training more of our biologists to maybe understand the computational aspect of things would be very desirable. The second area would be, which is already getting attention, is the area of looking into liquid biopsies, looking at ways of non-invasively trying to figure out if there are novel biomarkers, disease predictors, prognostic indicators that we could use by looking at ways by which we don't have to invasively go into and do surgical intervention. And the third area, I guess, which again has been at the forefront over the last maybe few years, is development of novel immune targeting therapies. So in this regard, again, immune checkpoint inhibitors are new, and now there are also strategies to look at the cell surface, glycocalyx, and how they interact with cancer cells, and the ability of normal cells to probably avoid that. So the idea would be then to design combination therapies where we could look at existing chemotherapeutic drugs with novel immune targeting or glycocalyx targeting moieties. So these are the areas that I think could be areas to invest in the next few years. Yeah, I think when it comes to pursuing a career in science for the young people who are coming in, I mean, definitely it's a very competitive arena right now. It's just different from 30 years ago. But at the same time, I mean, technology has advanced. We know a lot more about a disease, the biology of it. We have a lot better tools in terms of investigating. But I think the central thing that at least is very close to my heart, and what I have done over the 20 plus years of my career in cancer biology, is to question the dogma. So the idea always is to be able to find something novel, to find something where you basically are trying to defy dogmas. And that's how I think science moves forward, when you question what is expected to be a conventional dogma, and then you move the field forward. So for the young scientists, I think what I would have to say is believe in yourself. If you believe that you have something that is impactful, that is potentially going to change the way things are and the things are going to be done, then stay in the race. Believe in yourself and stick to your guns. And the rewards might take a while to come, but in my personal opinion, that is the way to be able to become impactful, to be able to make meaningful discoveries when you stick to what you believe in. So I think that would be my one very simple advice to people, to young scientists who may be venturing into this arena at a very, very exciting times in science. We have a lot of tools, we have a lot of technology, and I think this is a time when you could explore a lot of new things. Yeah, I think that's a very important question that I've asked myself, and a lot of people ask me as well, particularly for those of you who know me, that I'm an avid athlete and have always been for years and years, and this is something that is very close to my heart, and something that I still continue to do at a competitive level. My family obviously is very important to me, and the work I do. The people that I work with have always been like family. And so it's been an amazing run for the last maybe 30 years or so. And so I think if I had to really think about how I do all what I like to do, I use a different way of approaching it. I mean, a lot of us think about time management. And I usually say time is finite. You know, you have 24 hours in a day anyway. You can't stretch it. But I think it's all about managing your priorities. So if your priorities are in order, and the second most important thing that goes with it is to be disciplined. If I feel like I really am I'm passionate about doing something, and how do I bring it into the context of my priorities, then I have to find a way to be disciplined about it. So I think two important things: set your priorities, what is really important to you, and then be able to stick to it and be disciplined about it. And I think that's what I have practiced. I continue to practice, and I mean, yeah, we have done reasonably well, and with the lovely people that I have surrounded myself with, particularly in the context of this paper, the work of my research associate Kartini Iskandar has been instrumental in where we are, and many other colleagues who have helped me over the years to build this. Particularly, I would like to identify Dr. Jayashri Harpara, who has been my right hand in all the work that I've done here at NUS. And the wonderful support of the people around me, like yourself. I mean, that's what I think is the strength.